Ефим Исакович Зелманов je rusko-američki matematičar rođen u Sibiru 1955. godine. Poznat je po svom radu na problemima iz oblasti kombinatorike i algebre, kao i po rešavanju čuvenog Burnside-ovog problema postavljenog davne 1902. godine. Ovaj problem jednostavne formulacije fascinirao je matematičare širom sveta decenijama, te se njegovo rešavanje smatra jednim od najistaknutijih matematičkih dostignuća prošlog veka. Na Međunarodnom kongresu matematičara u Cirihu 1994. godine uručeno mu je jedno od najviših svetskih priznanja, Fildsova medalja, koja se na svake 4 godine dodeljuje matematičarima mlađim od 40 godina za izuzetan naučni doprinos. Profesor Zelmanov je i višegodišnji gost svetskog naučnog skupa matematičara i informatičara Heidelberg Laureate Foruma, koji se već tradicionalno svakog septembra održava u univerzitetskom gradu Heidelbergu u Nemačkoj. Upravo sa ovog skupa, u razgovoru za Centar za promoцију науке, istaknuti matematičar govori o svom životu, naučnoj i profesorskoj karijeri, razlozima za napuštanje Rusije i odlazak u Ameriku, kao i o značaju i uticaju koji je Fildsova medalja imala na njegov život i dalji naučni razvoj. What is the importance of the problems you are working on?
Well, I work in algebra. This is kind of one of the fundamental areas of mathematics. In general, all areas of mathematics are closely tied to each other. And it's very difficult to separate one of them from the others. This is one of the basic areas of mathematics. So in order to study other areas, you have to study algebra. And recently it became important in its own because it plays a very big role in the modern communication business, cryptography, coding theory, and so on.
And what are the problems of the group theories you are currently working on?
I always work with infinite groups. I like infinite groups.
Why?
I don't know. Group theory, it's all sort of very difficult to explain, but to explain what is group theory, every object has some symmetries. And symmetries have the same common kind of rules. You can do symmetry is some transformation that changes it to itself. You can do one symmetry after another, it's like multiplication, you can reverse them. And formally, this subject of symmetries is studied by group theory. One of the first to understand the importance of the group was Évariste Galois. He was killed at the age of 20 on a duel. He did not have any formal education because he failed entrance exams. And he wrote this paper, which Hermann Weyl called the most influential mathematical paper ever. He wrote it since he had no illusions about his ability to shoot and could predict the outcome of the duel. He wrote it the night before the duel.
What was that paper about?
About the role of symmetries and solutions of equations and radicals. But when physicists in 20th century started to study elementary particles, they knew which question to ask. It's very important to ask the right question. And they asked about symmetries. So whether it is a solution of equations and radicals or elementary particles, or it's all symmetries and groups.
And what makes it more difficult for you, being a professor or a scientist?
But I don't distinguish. I always like to teach to a certain extent. Because look, of course, you teach to freshmen some calculus, which was known since the 17th century, but you teach them as though you invented it yesterday. The greatest mathematics ever, and you can tell them.
And as you are a winner of the Fields Medal, can you tell us a bit more what does that medal mean to you?
What that means to me?
Yeah.
Oh, it changed my life. Because for the first year after that, I felt like I moved from mathematics to public relations. Mathematicians generally are shy creatures. They are not used to giving interviews.
And well, it was maybe a good opportunity to popularize math and what you are doing.
I tried, because what is the purpose of giving me a Fields Medal? Well, it brings some perks in life, but basically the purpose is probably to, in this way, to increase awareness of mathematics. So I have to go give talks.
And someone compared it to the Nobel Prize. They say that it's
every
even more
prize
difficult.
has its own features. Nobel Prize is usually, the average age of a Nobel Prize in physics is 65. So usually it is given for lifetime achievement, often for a work that was done 40 years ago. And Fields Medal is given to a person who has not turned 41.
So is it difficult to get it when you are so young?
But on the other hand, mathematicians usually do their best works when they are young.
Okay. When someone Googles your name and what you are doing, it's written that on Wikipedia that you are a Russian-American scientist.
Well, I was born in Siberia and lived there until, let us say, 1990, 35 years. Usually in America, after I say that I'm from Siberia, people ask what have I done to have got there.
And why? What was the main reason for moving to the United States?
Oh, United States. There are many reasons. Many. At that time, Soviet Union was collapsing at all. The country was disintegrating. Besides, in America it is not an issue, and at least until now I hope it will continue that way. But in Russia it was a big issue. I was ethnically Jewish, and my children were 50% Jewish, 50% Armenian.
Was difficult to stay there?
No. That is, I passed through that. When I came to America for the first time in '89, I have a very good nose for it. I noticed that nobody is interested in my origin, because everybody is from somewhere. If not, then their parents, their grandparents. Nobody cares. So I thought, that's where I want to be.
So, what is the main difference between the American and Russian approach to mathematics?
Well, there is no difference. Yes, there are some differences, okay. In general, there is no American mathematics, Russian mathematics, German mathematics. There is world mathematics, Serbian mathematics. There is world mathematics. And people in all these countries work on the same problems. The difference was that in America, you made bachelor's degree in one university, you go to graduate school to another university, postdoc on a third university, then you maybe get position in a fourth university. You constantly move. In Russia, in the Soviet Union, there was very little mobility for reasons. So usually people stayed all their life at the same place. On one hand, it was good, you could have a school. On the other hand, there were some elements of inbreeding.
And how did that affect mathematics and the process of learning?
You learned very deep, but a narrow area.
In Russia?
Yeah.
In America?
More wide. They especially encourage you to move, so you would see what other people do.
I see.
And different points of view.
But do they go so deep?
Eventually you go very deep, but in a seminar, of course, it is easier to learn some subject.
Okay. I heard from your previous interviews that you often like to say that mathematics is half art and half science.
Yes, for those who do it. Of course, we like to talk about applications, and in fact, never in history mathematics enjoyed such a support, including financial support, and such prestige as now. Listen to talks, even mostly they're in computer science, but that's a branch of mathematics. You will see how it works. At the same time, for those who are inside, it's art. That may be true for any science. For those who are inside, it's art. But maybe in mathematics, it's more pronounced.
And do you think that the art of mathematics should become more accessible to more people, or you should stay reserved for a small privileged group?
Both. Both. We have to do our best to popularize it, because the society that supports mathematics has a right to know. At the other hand, imagine that playing violin became extremely useful, and they decided that all children should learn to play violin. Some will learn and some only up to a certain point. I'm tuneless. I wouldn't be able to do it. Same with mathematics. It is not true that everybody can do it.
What do you think it depends most on?
You need some special abilities, like playing violin.
And maybe it's also up to teachers.
The teachers are central people. They're very important.
Did you have a good one?
Yes, I was very lucky. In my middle school, I had a very good teacher of mathematics. She was not a great problem solver herself. She did not need to. But I noticed soon that I solved these problems better. But then she was very encouraging. She noticed it. She was so happy. And it was important.
You think it's more important to have someone who's encouraging being a professor than someone who's good scientist, good mathematician?
Oh, but I'm talking about a middle class,
okay.
A middle school teacher.
Okay, I see. Thank you very much.
Thank you. At the university, it's a big mystery. What do you need to be to have good students?
It's a mystery for you as a professor still?
Yes, because there was Kolmogorov, the greatest Soviet mathematician was Kolmogorov. He was a terrible lecturer. To start with, he spoke with ultrasounds. It was impossible to look. He had created such a school.
Well, when you look back at the whole your career, what would you highlight as the biggest achievement?
Biggest achievement? At a certain point, doing mathematics is like weightlifting. You exercise in the gym and it doesn't go. And then I remember this moment. I was maybe 20, 22, 23. Felt that, you exercise, and then the strength appeared. I was always a problem solver. Problem solver, you jump on a problem and don't let it throw you.
What was the problem you were working on when you were 22?
It was first an associative algebra. Then, I finally I solved this problem for which I got the prize. It was the age maybe 35.
So like the last chance to get a Fields medal?
Yes, I was 38 when I got it.
Nice. Thank you, Zelmanov. Thank you very much.
Thank you. It was a pleasure.
Yeah.
Only one person in the world got 2 Fields medals. He will speak on Friday. Kasher Birkar. And he got 2 Fields medals because he got it in last year in Rio de Janeiro, and his medal was stolen. He left a bag in the hall, and since they have cameras, everything, some people from outside came, took his bag.
Took it.
So they gave him the second. So that's the only person.
Okay, but one is enough, I guess, as well, for all life.
Thank you very much.
You're welcome.